Swayam Prabha. Digital India. Educated India.
We are going to discuss unconstrained and dimensional optimization technique, unrestricted search methods. We are going to directly do the problem. Find the minimum of f of x into x minus 1.5 by starting from 0 with an initial step size of 0.05. Now we have a solution. The function at x1 equal to 0 is simply substitute x1 equal to 0 mean x equal to x1. Therefore, what happened? A corresponding f1 equal to 0.0 because 0 into anything is 0. If we try start moving in the negative x direction, x suffix minus 2 equal to substitute in the given function f equal to x into x minus 1.5 is minus 0.05. So, f2 equal to minus 0.05 into minus 0.05 minus 1.5, simplify minus into minus plus, the net value is 0.0775 and compare f1 and f minus 2, f minus 2 is greater than f1. Therefore, the assumption of unimodality indicates that the minimum cannot lie towards the left of x suffix minus r. Thus, we start moving in the positive x direction and obtain the following results and accelerate. Let us start with number 1 and take the value of s equal to 0 and xi equal to xi plus s, it is also 0. Substitute the given function and where what are all the value of x equal to 0 put it, therefore, fi equal to f of xi equal to 0 and check it out fi and fi minus 1 initially it not possible, therefore, not applicable. Now you go to x2, that is I equal to 2 and we have a step size is 0.05 and xi equal to xi plus s, that is 0.05 plus 0 is 0.5 and function is x into x minus 1.5 is minus 0.0725 and there is comparison of fi and f greater than f suffix I minus 1, therefore, no possibilities, no. Next you take the value of x I equal to 3 and the value of s equal to 0.05 plus 0.5 is 0.1 and xi plus 1 is a 0.1 and f of f suffix I equal to f of xi equal to minus 0.140 and check fi and fi minus 1 and no possibilities, therefore, no. Similarly, you go to the 4 I equal to 4 and value of s equal to 0.20 and add with s of xi equal to 0.20 and substitute in the fi, that is f of xi is f of 0.20 is 0.260 and no value, mean fi and greater than fi minus is no. Next one is 0.40 and that is I equal to 5 and value of s equal to 0.40 and xi equal to xi plus s is equal to 0.40 and substitute the f of xi equal to minus 0.440 and no. Next sixth I equal to 6, value of s is 0.80, therefore, xi equal to xi plus s equal to 0.80, then fi equal to f of xi is minus 0.560 and no. So, you take I equal to 7 the value of s equal to 1.60, fi equal to f of xi equal to 0.160, and check it out, previous value and this value, and there is a change. Therefore, fi is always greater than fi minus 1 comes, stop it. Therefore, the optimum point can be seen, and the x of optimum is x suffix 6 equal to 0.80. Now, let us go to the problem 2. Find the minimum of the function f of lambda equal to lambda power 5 minus 5 lambda cube minus 20 lambda by unrestricted search with the fixed step size is 0.1 starting from lambda equal to 0. Now, the solution is the function value at x1 equal to 0. Now, f1 is equal to 5, because x1 equal to 0, and then what happened? The given function is restricted, so that f1 equal to 5 will come. Now, let us try with the starting point in the negative x direction. X suffix minus 2 is minus 0.5, then f suffix minus 2 is 7.00499 will come. Compare f minus 2 and f1, and f minus 2 is greater than f1. Therefore, the assumption of unimodality indicates that the minimum cannot lie towards the left of x2. Thus, we start moving in the positive x direction and obtain the following results. Now, we take the value of I equal to 1, the value of s equal to 0, x suffix I equal to x suffix I plus s equal to 0, and corresponding value is 5 will come, and then check it out, fi and fi minus it is not applicable, and go to this 2, I equal to 2, value of s is 0.1, and xi is 0.1, and f of 0.1 is 2.995, and comparative with the previous and one, it does not exist, therefore no. Similarly, go to 3, 0.1, 0.2, and f of 0.2 is 0.96032, no. 4, 0.1, 0.3, minus 1.1325, no. And then fifth one, value of s is 0.1 and value of xi equal to 0.4, and f of 0.4 is minus 3.309, and it is also no. You take a sixth I equal to 6, value of s is 0.1 and xi equal to xi plus s is 0.5, and the value of f of 0.5 is minus 5.593 and no, and I equal to 7, value of s is 0.1, xi equal to xi plus s is 0.6, and then f of 0.6 is minus 8.002, and check with the previous one, fi is less than fi minus, that means no, and then you go to 8, 0.1, 0.7, minus 10.546, no, and 10 also you take it 0.1, 0.9, minus 16.05, no, and then 11 also does not exist, and 12, 0.1, 1.1, to minus 22.044, no, and go on like that, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, till 21 check, fi greater than fi minus 1 does not satisfy, whereas if you go to 22, the value of s is 0.1, therefore xi equal to xi plus 1 is 2.1, and corresponding f of 2.1 is minus 42.46, and check the inequalities, it becomes yes. Therefore, optimum point can be seen to be x optimum equal to minus 43. Therefore, x optimum equal to x suffix 21 is 2. So, this is a way we can find out the what unrestricted values using the substitution of the step size, you can get the value of x. So, this is the one of the ways of finding the optimality of the given function. Now, we are going to discuss the problem 3. Find the minimum of function f of lambda equal to lambda power 5 minus 5 lambda cube plus 20 lambda plus 5. The previous problem it become a plus 5, right. The same problem we have to take it, and then unrestricted search with the accelerated step size from the initial point 0.0 with a starting step length of 0.1. So, the function value at x1 equal to 0 implies f1 equal to 5. Now, x suffix minus 2 equal to minus 0.1. Therefore, f suffix minus 2 equal to 7.00499. So, compare with the f suffix minus 2 and f1, which is greater than one another. So, the minimum cannot lie forward left of x suffix minus 2. So, we starting in the positive x direction and obtain the following result: I equal to 1, 2, 3, 4, 5, 6, 7. So, the value of s is equal to 0, 0.1, 0.2, 0.4, 0.8, 1.6 and 3.2, and x suffix I equal to xi plus s, and we have 0, 0.1, 0.2, 0.4, 0.8, 1.6 and 3.2. Now, we have fi equal to f of xi. F of xi is 5, 2.995, 0.96032 and minus 3.309 and minus 13.23 and minus 36.99, 112.70 for initially not applicable, and followed with that the sixth step it is not changed, whereas the last step the changed in the inequality. Therefore, fi greater than fi minus 1. Therefore, it reached the optimum. Therefore, x equal to 1.6. Now, we have a Fibonacci method. So, the flow chart says that enter with n, a1 and b1, and initially f naught and f1 equal to 1, and go to the next f2 equal to 2, because 1 plus 1 is equal to 2, and fl is equal to fl minus 1 minus fl minus 2. If L is L plus 1, then fl, otherwise you go to L equal to n. If yes mean, continue the next step. If no mean, go to L to L plus 1. If L equal to n, then L2 star equal to f suffix n minus 2 by fn into b1 minus a1. When j equal to 2, therefore, L1 equal to b1 minus a1. Is L2 star greater than L1 by 2? Otherwise, x1 equal to a1 plus L2 star and x2 equal to b1 minus L2 star. And if you have x1 equal to b1 minus L2 star, x2 equal to a1 plus L2 star, and calculate f1 equal to f of x1 and f2 equal to f of x2. So, you compare with the f1 with the f2. If f1 is greater than f2, a1 equal to x1. If f2 is greater than f1, then b1 equal to x2. If f1 equal to f2, then a1 equal to x1 and b1 equal to x2. Therefore, L2 star equal to f1 minus j of b1 minus a1 by f1 minus of j minus 2. Therefore, find the new L2 of f1 minus j into L1 by f1 minus j minus 2. So, find new L2 star of f1 minus j L1 divided by f1 minus of j minus 2, and check that j equal to j plus 1. is j equal to n, yes mean print, and no mean you go to the backtrack of b. B is you have to check it out, L1 equal to B1 minus A1, continue the process, and if j is n, then print A1 and B1 and Ln equal to B1 minus A1 and then stop the iteration. So, this is called it as Fibonacci search method. Now, we have a problem, minimize f of x equal to 0.65 minus of 0.75 by 1 plus x square minus 0.65 x into tan inverse of 1 by x. So, in the interval 0, 3 by Fibonacci method using n equal to 6, note that the objective is equivalent to one stated in the example previous. So, here n equal to 6 and T naught equal to A1 approximately B1, which is equal to 0 minus 3 equal to difference of this one equal to 3, because upper integral minus lower integral 3 minus 0 equal to 3. Now, the rule is for the Fibonacci search L2 star equal to f suffix n minus 2 by fn into L naught. So, start with 6, n equal to 6, therefore, f suffix 6 minus 2 is f4 by f6 into L star, L naught. So, n equal to 6 here. Now, the Fibonacci numbers of the sequence is f1 equal to f suffix n minus 1 plus f suffix n minus 2, where n varies from 2, 3, 4 and so on. Now, you start initial 1, 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, go on like that. Therefore, f suffix 6 minus 2 is f4, here f4 is 5 and f6 is 13, f5 is 8, f6 is 13. Now, f4 by f6 into L naught equal to 5 by 13 into 3 is equal to 1.153846. Now, the position of the first two experiments, one given by x1 equal to 1.153846 and x2 equal to 1.53846, subtract them, we have 1.846154 will come. Now, f1 equal to f of x1 and f of x1 is nothing but substitute in the given equation 1, this is a 1, and then we have what f of x1 equal to 0.65 minus 0.75 by 1 plus x1 is 1.153846, substitute it whole square minus 0.65 into 1.153 into tan inverse of 1 by 1.153. So, that the value is 0.3217 minus 0.535568. So, this subtract and along and after getting this subtract it, so that we have the value of 0.20727 and f2 equal to f of x2. So, x1 already got it, x2 also got it, substitute it, so that f of x2 will get it. Now, you have to trace the point. Here x1 is 1.153846, x2 is 1.846154 and then the difference of this is equal to 0.115837. So, this lies here. Now, based on the graph, we have to go to the next step. So, x3 equal to the first point, that is x3 the value of x3 is equal to, you have to use the formula that initial value plus the difference x2 minus x1, and then x2 you know, x1 you know, subtract it, you get the value. So, f3 equal to f of x3, substitute in 1, we have the value of this one is equal to 0.29136. Now, you take f1, f2, f3, f1 point is here, f3 point is here, that is x1 equal to 1.538 is here, and compare this one, 1.84861 will come here, and x3 is 0.692 is here. Then subtract these two corresponding function, we have f3 is here, substitute this one in f1, f1 here, f2 here. Now, comparatively study with all these things. Now, f3 looks here, and f1, f2 coming the above of f3, then you start. So, the x3 is nearer to x1, and x3 and x2 is far away in between x1, therefore, x1 minus x2 difference find out, and initial value 0 plus x1 minus x3 equal to 1.153846 minus 0.692308, subtract them, we have 0.461538, and take this value, substitute in f4 equal to f of x4, which is equal to 0.65 minus 0.61829 minus 0.341516, and then net value is minus 0.39806. Now, x4 you know, x3 you know, x1 you know, take the graph, comparative x4, x3, x4 is lesser than x3, x3 is lesser than x1, and the comparative study with the x4 and x3 corresponding function is f4 is minus 0.309 and f3 is minus 0.291, f1 is minus 0.207. Now, x3 and x4 are nearer, and then we have a L4 of a positive. Therefore, x5 equal to 0 plus x3 minus x4, and that value substitute it, you can get 0.23077, and substitute in f of the function. So, f of x5 equal to 0.65 minus 0.712078 minus 0.2016, we have minus 0.26, and take the value of x5, x4, x3. x5 is 0.02377 and compare with x4, x4 is greater than, therefore, x5 less than x4, x4 less than x3. Now, the value of f5 you find out minus 0.26, f4 is minus 0.309 and f3 is minus 0.291. Compare with the f5, f4, f3. Now, we have to take L5 is f5 to f3, because compared to f4, f3, f3 is lesser than F4 is lesser than F3, and then F5 and F4, F5 is greater than F4, therefore, we have to take the difference of F5 and F3. Now X6 equal to X5 plus X3 minus X4. Therefore, we have to take the value of 0.46154. Now, we have F6, f of S6 you find out minus 0.309809. Now, X5, X4, X6 you compare them. X5 is lesser than X4, X4 is lesser than X6, more or less they are equal, whereas you compare, you find the value of F4 minus 0.309 and F6 is minus 0.309 and F5 is minus F5 is minus 0.02636 and a comparative study here F4 and F6 are equivalent to nearly equivalent of 3 decimal places. Now we compare with what X5 to X6, so that X6 minus X5 divided by the value of L0. So, L6 you know, L0 you know, substitute it, you have 0.07692. Now, 1 by Fn equal to 1 by F6, F6 is 1 by 13 which is equal to 0.76923. So, this is the Fibonacci search of nearest to the value of this. Next, find the minimum function of f equal to lambda power 5 minus 5 lambda cube minus 20 lambda plus 5 by the Fibonacci search in the interval 0, 5 with n equal to 6. If n equal to 6 and L naught equal to 5, then L2 star equal to f suffix n minus 2 by Fn into L naught, which is equal to F4 by F6 into L naught, and F4 is 5, F6 is 13, 13 into L naught is 5, and simplify, so that the net value is 1.923076. So, choose x1 equal to 1.923076 and x2 is nothing but 5 minus x1 equal to 3.076924. Therefore, f1 is f of x1 equal to minus 42.71972 and f2 equal to f of x2 equal to 73.6016. Now, we have x1 and x2 corresponding f1 and f2. So, f2 is 13.6016 whereas f1 equal to minus 42.71972. Now, compare these two. The rule is initially we start with 0 because the interval 0 to 5 for x naught equal to 0 plus x2 minus x1 difference find out. So, x2 is 3.076924 and x1 is this value, subtract it, so that 1.153848 will come. Therefore, f3 equal to f of x3 equal to minus 23.71269 and we have a x3 and x1, we have x3 and x1 and x2. So, comparatively x3 and x1, x3 is nearer to x1 and comparatively x1, x2, x2 is greater than all x1 and x3 and we have f3 and f1. So, we have to take the values of the interval 1.15 to 5. So, 1.1538482 is initial plus x2 minus x1. So, x2 is 3.0769 minus x1 is 1.923. So, we have 1.1538 plus 3.0769 minus 1.923. So, that 2.307696 will come. So, you got x4 now. Substitute in the given function f of x4 find out minus 37.15415 will come. x3 corresponding f3, x1 corresponding f1, x4 corresponding f4. Now check it out. Comparatively x3, x1, x3 is less than x1, less than x4, and f3, f1, f4 compare them. f3 is greater than f1 and comparatively f3 and f4 is lesser than f3 and greater than f1. Now based on this you have to choose the value of what? The nearest of which interval is x5 is 1.153 plus 2.307 is x4 minus 1.92 is x1. So, you have x5 equal to 1.538 and f5 equal to f of x5 which is equal to minus 35.3575. Now, x5 corresponding to f5 is minus 35.35 and x1 is 1.92 corresponding to f1 equal to minus 42.71 and these two are nearer. So, f5 is greater than f1. Now, you take the limit x6 is x3 plus x4 minus x1, so that 1.923088. Therefore, f of x naught equal to minus 42.7198. Now, check it out. x5, x1, x6, x1 corresponding f1, x6 corresponding f6. Now, you compare f1 and f6, they are two decimal places, they are equal and integer also equal. Therefore, f1 is minus 42.71972 and f6 is minus 42.7198. Subtract them. Therefore, L6 by L0 equal to 1.538468 approximately 1.923088 by 5, which is equal to 0.76924. Therefore, 1 by fn equal to 1 by f6 equal to 1 by 13 equal to 0.76924. Now, we are going to discuss another problem. Find the minimum of the function f of x equal to 0.65 minus 0.75 by 1 plus x square minus 0.65 into x into tan inverse of 1 by x using unrestricted search method with fixed size is 0.1 from starting point 0. So, the technique is f1 of 0 you take it in the given function 1. Therefore, f1 of x equal to 0 is minus 0.1. You take f2 and x equal to minus 0.1 and substitute in the given function we have minus 0.188193 and x2 equal to 0.1 we have minus 0.188193. Go to f3, x equal to minus 0.2 equal to 0 minus 0.24 and f3 equal to x equal to 0.2, the value is minus 0.24969. Similarly, f4, f5, f6 and so on, find out. Now, you compare with f7 and f6, they are 2 decimal places or 4 decimal places, they are equivalent to one another. Now, it reaches optimum, therefore, x optimum is plus or minus 0.5. Next example, find the value of x in the interval 0, 1, which minimum the function f equal to x into x minus 1.5 to which within the plus or minus 0.5 using the Fibonacci search method. Here n equal to 7, L naught equal to 1, therefore, n equal to f suffix n minus 2 by fn into L naught, n equal to 7 you take it, therefore, f7 minus 2 by f7 into L naught, that is f5 by f7 into L naught. In the Fibonacci sequence, we have f5 is f5 is 8 and f7 is 21, right. So, this is the 5th term and 7th term. So, 8 by 21 into 1 equal to 0.380952. Now, the position of the first two experiments are given by x1 equal to 0.38075, x2 equal to 1 minus of 0.380952 equal to 0.61. Therefore, f of x1 substitute the function, f of x2 substitute the function, so that you can get f of x1 and f of x2 will come. Now, x1 in the graph x1, x2 plot it, maximum value is 1, minimum is 0 and f1 is minus 0.426, f2 is minus 0.54. Now, compare them, then it is lies between f1 and f2. Therefore, the start of 0.38095 plus 1 minus x2 equal to 0.380952 plus 1 minus x2 is 0.6190. Then you have to subtract, therefore 0.76904. This implies f of x3 equal to minus 0.562358. Now, we have a x1 and x2 and x3 corresponding f1 and f2, f3, compare them. f1 value is minus 0.426, f2 is minus 0.54, f3 is minus 0.56. Therefore, f3 is lesser than, f2 is lesser than f1. Now, you take the interval between x2 to x3. So, x4 equal to x2 plus 1 minus x3 and then x2 value know, x3 value know, substitute it, therefore, x4 will get it. Find f of x4 minus 0.551020, then x2 corresponding f of x2, x3 corresponding f of x3, x4 corresponding f of 4, f of x4 find out. So, f2 equal to minus 0.545, f3 is minus 0.56, f4 equal to minus 0.55. Now, compare them, it lies between x3, x4 and the interval start from the 0.619048. Therefore, x2 equal to 0.619048 plus x4 0.8571 minus x3 is 0.76190, so that 0.714288 will come. Therefore, f of x5 equal to minus 0.56122. Now, compare them. X5 got it, X3 got it, X4 got it. X5 corresponding F5 is minus 0.56, X3 corresponding F3 is minus 0.56, X4 corresponding F4 is minus 0.55. Now, F3 and F5 are nearly equivalent of the two decimal places. Compare with F4, F3 is lesser than F4. Now, we have the comparison with X3 and X5 with X1 starting point and X2 equal to 0.61904 plus X3 is 0.761904 minus X5 is 0.7142, which is equal to 0.646, which is equal to f of x6 equal to minus 0.555. Now, we got x6, x5 and x3. Compare them. F5 and F6 are F3 are nearly equal, and then F6 is greater than F5 and F3. Therefore, we have to choose x6 compare with x3 minus x5. So, x7 equal to 0.714216 and f7 is minus 0.56121 and we have L7 equal to what? 0.047688 and L7 by L0 equal to 0.047688. Therefore, 1 by f7 equal to 1 by 21 is equal to 0.04761.